The topic for this lesson is electromagnetic induction, Faraday's law and Lenz's law. Let's look first at electromagnetic induction and Faraday's law. The linkage between magnetism and generation of electricity gives rise to the phenomenon known as electromagnetic induction. The British scientist Michael Faraday discovered in 1831 that an EMF is induced in a conductor when it passes through a magnetic field or when a magnetic field passes through a conductor. The conductor or the field may be moving. This is also stated as Faraday's law. The factor that determines this induced voltage is phi, the rate of change of flux. Thus, E equals minus delta phi divided by delta T. If there are n conductors, then E equals minus n times delta phi divided by delta T. Since phi equals B times A, and delta A equals V times L square meters, where V is equal to the velocity of the conductor in meters per second. Thus, E equals delta phi divided by delta T, or B times delta A divided by delta T, which equals B times L times V in Webers per second. Therefore, E is equal to B times L times V in volts. Let's now discuss Lenz's law. Lenz's law states the direction of the induced EMF is such as to oppose the change that originally created the EMF. This is the reason for the negative sign in the equation, E equals minus n times delta phi divided by delta T. If a conductor cuts a flux of 600 microwebers in a time of 0.75 milliseconds, what is the value of the induced EMF? The change of flux, delta phi, is equal to 600 times 10 to the minus 6 Weber. The time change, or delta T, is equal to 0.75 times 10 to the minus third seconds. The induced EMF is E, which is equal to delta phi divided by delta T, or E is equal to 8 volts.